Hello everyone, welcome to the platform of Unacademy, India's largest online learning platform. So I welcome you all to this session of rolling once again. So before starting this session, let me give a brief introduction about myself. My name is Vidyapati Kumar and I have a 4+ year of teaching as well as research and development experience. I have done ME from Jadavpur University. I have worked at CSIR, Central Institute of Mining and Fuel Research, qualified GATE twice, and on the research papers publication of national and international journal of repute. You can follow me at unacademy.com at the rate of v.ksir. Here, currently I am teaching the strength of material full course. So basically this session would be more focused on numerical aspects of rolling operations. We are going to derive some of the results from this rolling operations. So basically we are going to derive some of the formulas from numerical aspects, and we are also going to see how these formulas are very much important from gate point of view. So there are some of the frequently asked concept that is frequently asked in gate and ESE. So those concepts we are going to tackle. So we are going to take, like, this is the first session of the numerical, and again in the coming future I would be taking the two more sessions which will be purely focused on numerical aspects of the rolling. Because let me tell you, my dear friend, from this rolling operations there are like frequently questions are asked from numerical, and if you can have a very good concept in that, you can very easily solve these problems. So it is very much important to focus in these aspects. So let's start it. Before starting it, if you haven't downloaded the Unacademy learning app, then you should download the Unacademy learning app, because currently I am teaching the free classes here, which is of strength of material, and tomorrow I would be teaching you the concept of shear center. Tomorrow I would be teaching you the concept of shear center, which is the newly added topic in GATE. Okay, so tomorrow I would be teaching you the shear center concept, which is in the strength of material. So you can join my classes tomorrow, that is 11 a.m. That will be 2 hours class. So this is the benefit of the Unacademy learning app. You can always go for the free classes, and the another is the paid classes. In that paid classes you have to pay some amount of money, like take the subscription, and then you have to watch the videos. So what are the benefits? You have the daily live classes. You can attend daily live classes, you can interact with your educator. If you have any kind of doubt, definitely you can resolve your issues. Courses are very much structured in nature. Tests and quizzes you can give, and unlimited access of the course content materials. And if you're planning for a plus subscription, go for a plus subscription, because it is worth it. 100% coverage of the syllabus would be there. Entire syllabus would be covered. Daily live classes are there, so definitely you will be getting the opportunity to interact with educator. You can also contact with educator if you have any kind of doubt. You can resolve your issues. Courses are very much structured in nature. Tests and quizzes you will be giving, and unlimited access of the course content materials. Apart from that, there is another subscription, that is iconic subscription. You will be getting all the benefits of the plus subscription, and getting the benefits of the plus, you are also getting another added benefit, that is personal coach. So you can choose any of your educator to be your personal coach, and that coach will help you throughout your preparation of GATE and ESE. And definitely that will also help you, they will also help you to make a good strategy, how to score a very good marks in the coming examinations. So there would be a study that would track your performance, that would monitor your what exactly you are doing, and what should be incorporated, new things that should be incorporated, new strategies that should be incorporated, your plus points, your minus point, everything would be told to you, so that your marks get boosted enough. And lots of question and answer would be given to you for practice. So you will be having mock test, you will be having practice test, you will be having question and answer test, so that you may not have to refer any other sources for the practice things. So these are the top educators of the Unacademy, as well as Unacademy has a lot and lots of batches for GATE and ESE, like mechanical, civil, electrical, electronics, production, industrial, so on and so forth. So if you want, you can always go and check for these courses, as well as these are the amounts for a plus subscription. If you want to get a subscription, that is for 1 month it is 5,500, for a 6 month it is 24,750. So these are the plans. So there is a new plan that has been introduced, that is 18 months plan. So for a second year or for a third year, definitely you can go for these kind of plans, whichever suits you, so that your preparations would be very much solid तरीके से आपकी preparation होगी. And if you are using these code that is my code SIRVK, then you will be getting a 10% off, as well as I will provide a personal mentorship to you also. So if you will be getting a 10% off, suppose if you are subscribing for a 12 months plan, so the prices would be 27,225. So definitely you are getting a 10% off, as well as I will provide a personal mentorship to you also. So definitely based upon your choice, you can always go and subscribe these plans. Okay, so let us start our discussion of the rolling. Let us start our discussions of the rollings, what we have started. Okay, so let's see what I have told to you yesterday class. So in yesterday's class I have derived some of the one or two formulas. So basically in this session we are going to study the entire mechanics of the rolling fundamentals things. Okay, so let's see. Suppose, so let me write it here. Suppose this is a roll, right? So this is the first half of the roll, and this is the second half of a roll. Fine. Now suppose that you are giving the billet. So there is a billet or a workpiece that has been fed to this like this. So this is a billet that you are feeding here, and this billet is in contact with this roller up to this point. Fine. So after this point it is like this. So with compression and shear, this is deformed. Fine. So there is a compression and there is a shear force that is acting here, and that force is deforming this billet. Okay, so let us assume that this is a plate. So let us assume this is a like this, right? So let us assume this length to be h naught. Okay, so h naught is what? This is the thickness. H naught is the thickness before the rolling operations. Okay, now this is the final thickness after the rolling operation. This is the final thickness, hf. Okay, I have discussed these things, that my roller is in contact, that this billet is in contact with this roller. Suppose this is the center of the roller. So you can see here that this billet is in contact with the roller at this point. Fine. So the contact of the workpiece and the roller starts at this point. Okay, and the contacts ends at this point. Fine. Again here also, in the second roller, contact of the workpiece and the roller is at this point, and contact of the workpiece and roller ends at this point. Okay, so let us assume this center of the roller to be A, this to be B, this to be C. Again, this center of the second roller to be A dash, this to be B dash, this to be C dash. Fine. So if you can see from this figure, you can understand that what is this BB dash? What is this BB dash? Is it the entries? It is the entry section of the billet. So can I write that? That BB dash is the entry section of the workpiece. Clear? Now this is CC dash. So you can very easily see here. Let me write it here. So here exactly you are doing the entry, right? So here is the entry. Fine. And here is the exit. Okay. So what we can understand from this, why you are so in hurry, Narendra ji, why you are so in hurry? I will definitely tell you. I will definitely tell you each and everything what is necessary for throughout the sessions. Don't worry. Don't worry. Okay. Please adhere with me. Please stick with me, and definitely I will explain each and every points. Each and every points. Okay. Please have some patience. Now see here. So we can see here that entry is there, right? So this is the my workpiece is entering at this section. So this is BB dash and this is CC dash. So now I can write here that CC dash is the exit section of the workpiece. And moreover, in yesterday's class, I have told you that in a rolling operation, the workpiece is subjected to some kind of state of a stress. Do you remember the state of stress what I have explained you in yesterday's class? Do you remember the state of stress? Tell me. Tell me the state of stress. Tell me the state of stress. Tell me the state of stress during rolling operations. I want answer from your sides because I have explained this in the yesterday's class. Okay, tell me the answer. Give me the answer in the comment box, and I will definitely love to see your answers. Now see, this is the B and C. Fine, let us understand. Tell me the answer. I'm expecting your answers. Okay, now see here. This is B and this is C. Fine. So understand that this is the radius, right? So this is the radius of the roller. That AB and AC is the radius of the roller. Now see, understand, earlier this was H0. Earlier the H0 amount of billet is entering. Now it is HF. Now it is HF. So what will be this? What will be this? This will be delta H by 2. And what is this delta H by 2? That would be H0 minus of HF by 2. Fine. This length would be delta H by 2. Fine. I have explained these things. So what is this distance? What is this distance? This is R, radius of the roller. This is also R, radius of the roller, right? So if I would write this to be C, point C, so this whole AC is what? AC is R, radius of the roller, right? Now this AC, this A, okay, so here is C, so let me write it this to be D. Okay, this to be D. So this AC is R. So what about this AD? So can I say that AD will be nothing but R minus of delta H by 2? R minus of delta H by 2. And in yesterday's class, okay, so I haven't got any kind of reply. So in yesterday's class, what I have told to you, my dear friend, understand here that the state of stress would be this. See, it is rolling. So roller is rolling in this direction. So this is the roller. See, this is the roller. From here you are giving the billet, and this is the deformation that you will be having. So what is the state of stress? So it is rotating in this direction, it is rotating in this direction. Okay, so this is which direction? This is counterclockwise direction. Fine. Now this roller is rotating in this direction, this is clockwise direction. Fine, this is clockwise direction. These are the radius of the roller, these are the radius of the roller. Now understand, throughout this the forces would be like this. Throughout this the forces would be like this, right? So you can understand that this entire, suppose if I will be taking a small elemental section here, that is here, this is, so this will be entire, this would be subjected to a compressive force like this. These will be subjected to this compressive force like this. Understand, this is the compressive force, this is the compressive force from this side, and compressive force, this roller will also give a compressive force in this side. Now understand, this roller is moving in this direction, so a shear force would be acting in this direction, and again this roller is moving in this direction, so due to the slip, shear force would be acting in this direction. So you have the state of stress that there is a compressive force which is acting in this direction, there is a shear force which is acting in this direction. Now there is shear force that is acting in this direction, so to complement this shear, a complementary shear stress would be acting, which will be in this direction. Fine. So this is the state of a stress, this is the state of a stress. So this would be compressive stress, and this would be shear stress, this would be shear stress that is acting. So state of stress is compression plus shear. Okay, now understand here what I was telling to you. So this is a roller, so this is a roller, what is the, so this is a roller, so what is the velocity with which this roller is moving? So let us assume VR, that would be rotating with pi dn by 60, pi dn by 60, where d is the diameter of roller, VR is the roller velocity, and n is the revolution in rpm. Fine, it is rotation in rpm. So now understand here, that let us assume one more thing, that at the b point, at the point b, the entry is there, so workpiece is getting entered here, right? So let us assume that at point b it is entering with a velocity of vi. Okay, so vi is the velocity with which, so it is an initial velocity with which my billet is entering. Okay, now at point c my billet is getting exit, so at point c billet or workpiece is exiting. So here the velocity of the exit would be, assume it to be vf. Okay, so let me write it here. This vi would be initial velocity that is at the inlet, or that is at the entry. Vf would be the final velocity that is at the exit. And what is the Vr? We have assumed Vr to be the velocity of roller. So if I would be asking you, at the entry section, what would be the rate of entry of workpiece? This workpiece is entering at this section, right? So this workpiece is entering at this section. So what is the rate of entry of this workpiece? So can I say that rate of entry would be like this? So rate of entry of workpiece. What is this? What is the initial thickness? Is it h naught? Okay. What is the width? See, the width of the plate would be like this. Okay, the width of the plate would be like this. So let us assume width to be constant. Okay, so h naught into b. So this is the area. Now by what velocity the billet is entering or the workpiece is entering? Is it vi? Okay, so it is vi. Let us write it is vi. Okay, now understand what is the units. What is the unit of h naught? Is it mm? What is the unit of width? Is it mm? What is the unit of velocity? Is it mm per second? So what is the unit? Mm cube per second. Okay, now what is the rate of exit of workpiece? So at what point my workpiece is exiting? See, this is the point at which my workpiece is exiting. Now here, what is the height we are getting? This is the height. So what is the length of this height or the thickness? Is it hf? Okay, by what velocity is moving? It is moving with the vf velocity. What is the width? So see here, I have assumed that width to be constant because basically the rolling operation is done to reduce the thickness. That is this thickness reduction is there. H naught was earlier, H naught was there, now HF is there, so width would be same. So if width would be same, so B is the width at the initial condition and B would be width at the final conditions. So based upon these assumptions, I can write HF into B into VF. Now this is also the same. What would be the unit? The unit would be mm cube per second. And one most important thing, rate of flow of workpiece should be constant throughout the rolling operation. This is the most important condition. So if this is the condition, so can I say that H naught B Vi should be is equal to HF into B into VF. So from these two equations, I can say this B and this B will be cancelled out. So we are left with this equation, that is HI, or better to write H naught by HF is equal to VF by Vi. Now from the figure, what you can see, H naught and HF. So H naught is greater than HF. Yes or no? So can I write that H naught by HF is always greater than 1? Yes or no? So if I would be able to write this, so can I write that H naught by HF is greater than 1? So if it is greater than 1, so I can write like this is greater than 1. VF by Vi, right? Because this is H naught by HF should be greater than 1. It is the condition. Now if I would put it here, what is the condition that I am getting? Understand, what is the condition that I am getting? Am I getting that Vi should be less than VF? That is what is the meaning? That final velocity is going to be greater than the initial velocity. What is the meaning? That suppose that if billet is entering at 5 mm per second, so the final velocity may be 10 mm per second. So what I can see from here, that this is greater than this, right? This is greater than this. So this is the meaning. Now understand, अगर यहाँ पे हमें क्या मिल रहा है, यहाँ पर मुझे ये मिल रहा है कि मैंने वर्कपीस को डाला, ठीक है, I have put this workpiece inside this roll, and so earlier velocity was less, now velocity is more. So can I say that, suppose this is B point, let us assume this to be E, Let us assume this to be F, G, H, I. Suppose there are some kind of points throughout these rollers. So can I say that the velocity of B would be less than velocity of E? Why? Because we have seen that earlier at the entry section velocity was less, and at the exit section velocity is more. So it clearly means that as the metal is subjected, as the metal is going from entry to exit, its velocity is going to increase, right or wrong? So VB would be less than V. It simply means that V would be less than VF. It simply means that VF would be less than VG. It simply means that VG would be less than VH. It simply means that VH would be less than VI. So this is the basic meaning, that entire throughout this B to C, my velocity is going to increase. My velocity is increasing. Okay, now here comes a concept of a neutral point. Here comes a concept of a neutral point. So there is a one point. So assume that there would be a one point. I'm just removing these points. Oh. Just a minute. Now understand. So what is the meaning? That there would be a some point at this roller, at this contact, that is known as N. That is known as N. And what is this N? This N is the neutral point. What is this neutral point? We have seen that velocity would be gradually increasing. Velocity would be gradually increasing throughout this. Now velocity would be gradually increasing, so we have also seen that there would be a velocity of roller, that is R. So there would be a some point, which is N. So at this N point, the velocity at this point N would be equal to the velocity of the roller, and this is known as neutral point. So at this neutral point, what is happening? Velocity of N is going to be velocity of roller. Fine. So this is the velocity of roller. And this is the velocity of workpiece at point N. Okay, so this is the meaning. So there is one more concept. So there is a concept of forward slip and backward slip. Now understand the meaning of forward slip and backward slip. So there is a point N, there is a neutral point N. So we are actually, so what is the forward slip? So see, this is the billet, or this is the workpiece which is entering. So it is entering from this section and it is exit from this section. So slip means what? It is going to pass. So slip. So if the forward slip we are going to calculate, which velocity is more, VF or VR? See, here is the neutral point, and we have seen that the velocity of neutral point would be equal to velocity of roller. Now we also know that VF is going to be more than the VR. Just now we have derived these things. VI is less than VF, and hence based upon these conclusions I have written like this. Okay, so what we can say that VF is going to be greater than Vn. So due to this VF velocity, V final velocity, this workpiece will be slipped out. Okay, so what I can write, VF minus of Vn by Vn is going to give me the forward slip. Okay, so let me write the concept of forward slip and backward slip and again explain you. So there is a concept of forward slip which would be Vf minus of Vn. So Vn would be what? Velocity of roller by velocity of roller. Vn would be again, and that would be into 100. So this is the forward slip in percentage. What is the backward slip? What is the backward slip? Now see. So this Vf was the velocity due to which it is moving in forward direction. Now this velocity, that is the Vr velocity. So this here the Vr velocity would be acting, and this is the initial velocity. So can I say that due to this initial velocity, since initial velocity is less, so due to this a backward slip would be acting, and the magnitude of this backward slip is written by Vr. So always and always we are going to write with respect to neutral point. Fine. So what is the velocity of neutral point? Is it Vn is equal to Vr? So Vr minus of Vi by Vr is going to give me the backward slip. Understand? Let me write it here, and then you will be understanding. So Vr minus of V naught by Vr is going to give me the backward slip in the percentage. So what is the, how you can remember this formula? Just remember that always and always whenever we are calculating the slip, we always calculate with respect to the roller velocity, fine. And how exactly we are getting the roller velocity? Because Vn is actually is equal to Vr. Okay, Vn is equal to Vr. Fine. Now understand. So in yesterday's class I have told you the some of the formulas. Okay, so let me again rewind those things so that you may not have the problem. Okay, so see here, this is delta h by 2, right? So this is delta h by 2 I have calculated. This is r, and this angle, this alpha angle, what is this alpha angle? This alpha angle I have told you in the earlier class also, this alpha is angle of bite, okay. So now this angle of bite is also that that is the maximum angle that is subtended by the arc, right? So how you can find this? How you can find the alpha? See here, this is the, so I think that is a little bit complicated, so let me draw it once again. So this was the roller, fine. So let me draw the full roller. So this is the radius, fine, and like this is the, there is again roller like this and like this, fine. So this is alpha, this was what, this was h naught, this was hf, this was alpha, right? This was what, this was delta h by 2, fine. Hf minus h naught, that is the delta h, and this is r, this is what, r minus of delta h by 2. Clear? So I was talking about, this is, let this is to be a, b and d. So r cos alpha, so if I would be asking with you r cos alpha, so my r cos alpha would be, what? That would be delta h by 2, right? So I can write here that r cos of alpha would be is equal to r minus of delta h by 2. Right or wrong? From the geometry, r cos alpha is equal to r minus of delta h by 2. Okay, so from here what you can write here, that delta h by 2 is equal to r into 1 minus of cos of alpha. Clear? Just put this thing in this side. So again, delta H would be is equal to 2R 1 minus of cos of alpha, which is again delta H would be D into 1 minus of cos of alpha. So this relation I have derived in yesterday's class also. So just remember this derivation, this formula. See, even if you don't remember the derivation, that is not necessary. Derivation is really not necessary. But from understanding point of view, from the conceptual point of view, definitely understanding the derivation would make your concept very much clear. So this is the formula that is very much important. That is very much important. Now see here. Now see here. So let us assume this to be D, this to be point C. Fine. This to be point C, and there is a N, that is neutral point. Clear? Now see here, if I would be asking the what would be the tan alpha from this figure, what would be tan alpha? So can I say that tan alpha would be equal to BC by AC? Right or wrong? See here, this is the triangle. So let me draw here. Let me draw the triangle. So if you cannot visualize, let me draw the triangle. So this is the alpha, this is the point A, this is B, and this is C. Fine. So this is what? Perpendicular, this is hypotenuse, and this is base. So tan alpha would be BC by AC. Now it is clear. So I hope now it is clear to you. So tan alpha is BC by AC. What is BC? What is BC? So I don't know about the BC. So understand this BC. This BC is known as length of the deformation. Clear? So this is known as this BC. Let me write it here. BC, which is known as length of deformation. Okay. Now see here, my dear friend, in the triangle ABC, in this triangle A, B, and C. Fine, in this triangle. So in triangle ABC, what is there? What is there? I know what AB is my hypotenuse. So AB square would be is equal to BC square plus AC square. So I can write very easily that AB just a minute, AB square is equal to AC square plus BC square. Now I want to find the BC, right? I want to find this BC. What is this AB? Is it R? Is it R? Okay. So AB is R. So that was going to be R square. What is AC? What is AC? Is AC R minus delta H by 2? Put it here. Plus BC square. You don't know the BC. So you can find from here that BC would be R minus of delta H by 2 whole square plus, sorry, this is going to be is equal to, okay, so this is going to be is equal to negative plus of R square. Fine. This is the BC that you are going to get. Now if you would simplify this BC, you will be getting as, let this R square be here, so negative of R square plus of delta H by 2 whole square, or better to write it like that, delta H whole square by 4 plus negative of 2 into R into delta H by 2. Clear? Now if you would if you would open the bracket, so definitely this would is going to be change. This is going to be negative, this is going to be negative, this is also going to be positive. Now you can very easily say that you will be getting this BC. So from this you can see this r square and this r square will be cancelled out. So you are left with this thing, that is this two get cancelled out. R delta H minus of delta H whole square by 4. Now understand, what is this delta H? Is it HF minus of sorry, is it H naught minus of HF? Right or wrong? Is it H naught minus of HF? Okay, now see, this delta H is very less, very less. What is the meaning? What is the meaning? That suppose the 20 mm is the H naught is 20 mm. So basically HF comes to be 16 mm. So what is the reduction? Is it 4 mm? Is it 4 mm? Now if you would see from here, this is 4 square. So basically it is in mm, and definitely it is going to be square of that. So this entire quantity is going to be very much small. So here at this point we are neglecting this to be 0 for the sake of calculation. Again I am saying, for the sake of calculations, to make the calculations easy, hence we are neglecting this, because this is a very much smaller quantity when we are comparing with the radius of the rolls or radius of the roll. Fine. So what we are getting from here, BC is equal to root over R delta H. And what is this? This is the length of deformation. Understand? Now remember this formula. If you cannot remember the derivation, that's completely okay. That's fine. That's not a problem at all. But remember this outcome. Remember this outcome. In GATE examination, they asked find the length of deformation. Find the length of deformation, and you can find the length of deformation by using this formula. In GATE examination, they will be asking about the alpha angle of bite or the delta H or the diameter of the roll. You can use this formula. Fine. Now in the GATE examination, they might ask you about the forward slip and the backward slip. You remember this. At the neutral point, what is the condition of this neutral point? Neutral point, Vn is going to be is equal to Vr. These outcomes are very, very much important, my dear friend. Even if you don't remember the derivation, that is completely fine, but remembering the outcome is very much important. What is the outcome here? See, outcome was that always and always final velocity is going to be greater than the initial velocity. Clear? So these are the outcomes. What is the again outcome? State of a stress. What is the state of a stress? This is the state of a stress in a rolling operation. What is this? That is this thing. If in a question, if the diameter of roll is given or n is given, then you need to find the velocity of roll. You can use this equation to find the velocity of roll. Clear? So these important points should always be in your mind. Now come back to our thing. Now we were finding what is the tan alpha, how I can find the tan alpha. So tan alpha is what? BC by AC. Now we know AC, that is this is the AC, right? This is the AC. Now what is BC? Just now I have calculated, it is root over R delta H. So I can write that tan alpha, what I have written, it is BC by AC. Clear? What is BC? What is BC? Is it root over R delta H? What is AC? What is AC? Is it R minus delta H by 2? Now again for the sake of calculations, to make the calculation easy, we are neglecting delta H by 2, as this is small, so definitely this is also going to be smaller. But if you would ask with me, is it true? No, it is not true. It is not true, but definitely for the sake of a calculation we are doing these things. Fine. So to make the calculations very much easy, so this is going to be neglected. So now if this is going to be neglected, this formula reduces to be tan alpha is equal to root over of r delta h by r. So that would be what? Let us write like that, r square, that would be what? Root over of delta h by r. So we are left with this formula, tan alpha is equal to root over of delta h by r. Okay, so this is the formula that I'm going to get. So you can remember this formula also, or I would say to you that I have given you this formula, right? What formula? This delta h is equal to d into 1 minus cos alpha. Sometimes this formula is like, it is very much difficult to remember this formula, because see, again, delta h is there, radius of roll is there, and alpha angle of bite is there. So in that case you can always remember this formula. If you cannot remember that formula, you can remember any one of these formulas, okay? Because definitely this is again the relationship between the angle of bite, delta h and r. So what is these terminologies? Let me write it here once again, where alpha is what? Angle of bite. Delta is what? Delta h is change in the thickness, and which is also known as draft. Okay, which is what? H naught minus of hf. What is r? R is the radius of roll. Roller. Now till now, do you have any kind of confusion, any kind of doubts, any kind of confusion till now? Any kind of confusions? Any kind of confusions? Just ask with me if you have any kind of confusions. See here, this B is there and D is there, so this BD is known as contact length, which is R into alpha. I have told you this thing also, contact length. Till now, if you have any kind of doubt, then tell me. Otherwise, I will be telling you some new concepts, what is happening in here. Because here we can see here that roller is rolling, and here the billet is in getting the squeezed out. So during this operation, frictional force is acting. So we are going to analyze those frictional force and what is the force analysis is there in this case. So before moving ahead, I just want to ask with you, if you have any kind of doubt, you can ask with me. Okay, so assuming that you don't have any doubt, fine, you are understanding in a very great way. So that's completely fine. That if you are understanding in a very great way, that's very good. Now understand. So this is a roller. Clear? This is a roller, and again here is also a roller. Fine, these two are rollers. So what I can say to here, that I am giving the billet. So billet is of this thickness. Let me make it just like this. So billet is of this thickness. Now it is getting reduced. It is getting reduced to this. Fine. So we have also seen this is the entry point, right? So this is the entry section. Now this is, at this point the contact is getting removed. So this is the exit section. Now see what is happening. This is the B point and this is the C point. till now what we have seen. And see, this roller is rolling like this, right or wrong? This roller is rolling like this, and we have also seen that vi is the velocity which is acting here, vf is the velocity which is acting here. So if I would ask with you, if I want to find a velocity on this roller, what is the direction of the velocity? What is the direction of velocity? So is this direction would be like that? See here, try to understand. Just a minute. Is this direction of the velocity will be this direction? See, this would be the direction of velocity, because this is a roller and making a tangent. So on this tangent line the velocity would be acting, right or wrong? Right or wrong? So now what I can see from here, this is the tangent, and what is this? This is the 90-degree and this is the 90-degree. Fine. So you can very much easily see that this is a block, which is in contact, with this roller, and in this direction, velocity is acting. Now think about it, that if you are moving in this direction, so velocity is acting in this direction, so frictional force would be acting in which direction, my dear friend? So we know that frictional force always tries to oppose your motion, yes or no? So definitely it tries to oppose your motions. So by that concept we can say that my frictional force would definitely be acting in this direction, like this, force of friction, right or wrong? Now let us draw the free body diagram. Okay, so let us draw the free body diagram here. Okay, let us assume here I'm drawing the free body diagram. So suppose this is a roller, right? So this is my roller, this is the center of the roller. Now at the center of the roller, what is the this thing is acting? So this is the velocity, so this is the tangent I'm drawing. Now towards exit, opposite to velocity, neutral point. I have explained the neutral point, Gulshan Kumamat. I have explained the neutral point. What is the neutral point? Neutral point is a point at which the velocity of roller is going to be same. Velocity of roller, that point here, I have explained these things in great details, and even if you are asking in the same things, it really demotivates me. I've explained here that see, if the B point is there, I point is there, so there would be definitely points like this, so these points would be decreasing. Why it is going to decreasing? I have derived this, that is velocity at the inlet is going to be less than velocity at the final position. So what I can say, that this velocity would be more than this velocity. So that simply means that I am going from the, so workpiece is fed from the entry section to the exit section. So from the entry to the exit, velocity is going to increase. Why? Because VF is increased. VF is more than VI. So if I would ask about B, so if this point is something about E, F, G, H. So what I can say here, if this is E, F, G, H. So I can say here that VE would be greater than VB, VF would be greater than VE, VG would be greater than VF, VH would be greater than VG. So definitely there would be a point, on that roller that is termed as N, that is neutral point. In that neutral point, the velocity of roller would be equal to that point of in that roller, right? So that is known as VN, neutral point. Okay, that I have explained it. Okay, no problem. I hope now you understood. Gulshan ji, I hope you understood now. Okay, now understand here what I was trying to tell you. So I was trying to tell you that in this direction, the velocity would be acting like this, right? Velocity would be acting like this. Now in this direction, frictional force is acting. Fine, frictional force is acting. Now this is the line of action. So this is the line of action. Okay, so now just let me draw. This is the radius. This is the radius. So let me draw here. Now see, this is the block. This was the block, that is the billet, that is the workpiece which was at the entry. So it is in contact here. So it is in contact here, right or wrong? So due to this contact, a normal force will come. See, due to this contact, a normal force would be acting in this direction, right or wrong? So due to this, a normal force would be acting, that is N. Clear? That is N. So let me write here, Fr is frictional force, N is normal force, right? Now understand, this is a billet. So this is the workpiece. This is the workpiece. Now if I would draw this workpiece here, like this, suppose. So see, neutral, N is the N is the normal force, right? N is the normal force which is acting here. So again, the same amount of normal force would be acting in this direction. Clear? This is the same amount of normal force that would is going to be acting in this direction. Now see, frictional force is acting in this direction. So here the frictional force would be acting in opposite direction. Clear? That would be acting in the opposite direction. What is this angle? Is it alpha? Angle of bite, is it alpha? Yes, it is alpha. So if you would draw a triangle, here, what you can see, this is alpha, this is alpha, this is 90 degree. So what is this angle? Is this angle 90 minus alpha? Yes, so that angle is going to be 90 minus alpha. Now again see, this entire angle would be 90 degree. This entire angle would be 90 degree. This is 90 minus alpha. So what would be this angle? What would be this angle? Is this angle alpha? Okay, is this angle alpha? Now this would be alpha, this would be alpha, and this is the normal force that is acting in this direction. Now if I would make this normal force in this, if I would extend it in its line of action like this, suppose like this. Okay, now if I would extend the normal force in this, in its own line of action like this, so I can say here this angle would also be equal to alpha, right or wrong? Now let's analyze this part. Now let's analyze this part. Now let's analyze this free body diagram here. This free body diagram, that what I have got in this case. Let's analyze this free body diagram in the next slide. Fine. See here. So I have got, so this is my workpiece at the entry point. So here the force of friction is acting. Clear? Force of friction is acting. Here normal force is acting. What is this angle? This angle is alpha, and this angle is alpha. Now verify this. That is what we have got. That is what we have got in this free body diagram. That is what we have got in this FBD. Yes or no? So now once we got these things, now if we want to resolve these forces, now if I want to resolve these forces, I can very easily say, that this is alpha, so definitely here, somewhat here, my force would be acting, that would be n cos of alpha, and this would be in this direction, the force would be acting, that would be n sine alpha. Okay, now again, so this is a force Fr, frictional force. Now if I would try to resolve this frictional force, then I would be getting, what are the components? So here if I would resolve this, so I would be getting as Fr cos of alpha, and if I would resolving here, I would be getting like this, Fr sine of alpha, Fr sine of alpha. So this is what we are getting the force analysis. Now there is a condition. That condition is known as, self entry. So see here, what is the meaning of self entry? Understand that this is the workpiece that I am feeding here. So I am giving the workpiece from this entry end. So what we can understand, from this B point to the neutral axis, my frictional force is acting, and there should be a condition of self entry. self entry का मतलब क्या होता है कि मेरे पास ये वर्कपीस है, ये वर्कपीस को मैंने इधर से दिया, अभी जब मैं दे रहा हूं ना, विदाउट एनी अदर फोर्सेस, अभी कोई भी फोर्स इसको ना लगे और ये अपने आप ये इस तरफ से चला जाए, रोलर से जो फोर्स लग रहा है ना, तो एक समय पे क्या, न्यूट्रल पॉइंट पे, आफ्टर न्यूट्रल पॉइंट उसको कोई भी फोर्स एक्सटर्नल देने की जरूरत नहीं पड़ेगी, और वो अपने आप चला जाएगा बाहर, सो दैट इज द कंडीशन ऑफ सेल्फ एंट्री. ओके, so now understand what is the self entry. So in that, without any other forces, billet will enter. That is the condition of self entry. So for that condition of self entry, so you can understand that this force, this is the force which is acting in this direction, right? And this is the force which is opposing this direction. See here, understand, my workpiece is moving in this direction, right? So if I want that my workpiece should move automatically its own, so definitely this direction force, that is this direction, this should be greater than this. So can I write that Fr cos alpha should be greater than or equal to n sine alpha? Why? Because this is what we want, self entry condition. Okay, now if that is the condition, that Fr cos alpha is greater than equal to n sine alpha, so what I can write from here, that Fr by n should be greater than equal to tan alpha. Now see here, this is the n, this is the frictional force. You can see from here, frictional force is there. So you know that frictional force is nothing but mu into n. That is, frictional force by n is equal to mu, where mu is what? Coefficient of friction. Coefficient of friction. So this is the coefficient of friction. So I can write from here, substitute this. This is the mu. Substitute it here. Now what you will be getting? You will be getting as mu is greater than equal to tan alpha. Mu is greater than equal to tan alpha. Now understand. So this is the condition that what we have got, that coefficient of friction should be greater than or equal to tan of alpha. Just now we have derived some formula. What is that formula? Let's have a look. Have we derived this? Tan alpha is equal to root over delta h by r. Okay, so let's use this formula. This is mu is greater than tan alpha. So can I write that mu is greater than equal to tan alpha, which is greater than equal to delta h by 2, delta h by r, root over delta h by r, right? It simply means that mu is greater than equal to delta h by r, right? So mu is greater than equal to delta h by r, right? It simply means this. So I have written this, and this is the condition of self entry. So remember, condition of self entry is this: mu is greater than equal to delta h by r, where delta h is what? Draft. R is what? Radius of the roller. Fine. Okay, so this is the condition of self entry. Now again understand. So this is mu should be greater than or equal to root over delta h. Now if I would be asking with you, what is the minimum amount of frictional force, what is the minimum amount of coefficient of friction that is required for the self entry, भैया आप मुझे बता दीजिए कोएफिशिएंट ऑफ फ्रिक्शन की सबसे कम वैल्यू क्या होगी जिसको मैं दूंगा, वो ऐसा कोएफिशिएंट ऑफ फ्रिक्शन का मैं मटेरियल बनाऊंगा जिसके कारण सेल्फ एंट्री कंडीशंस हमारी ऑटोमेटिकली सेटिस्फाई हो जाए, एंड दैट इज व्हाट? दैट इज नथिंग बट म्यू मिनिमम इज इक्वल टू रूट ओवर डेल्टा एच बाई आर. राइट और रॉन्ग? Now from these equations, if you would understand, if I would do like that, mu square is greater than or equal to delta h by r. Fine. I'm squaring both sides. I have done squaring both sides. From here what I have got, delta h would be greater than or equal to, delta h would be less than or equal to mu square r. So from this equation, what we can understand, this is going to be your draft. Now see, this is the draft which is less than or equal to, means what? म्यू स्क्वायर आर से छोटा भी हो सकता है या म्यू स्क्वायर आर हो सकता है. तो अगर मैं आपसे पूछूं व्हाट इज द मैक्सिमम पॉसिबल ड्राफ्ट, इफ इन द क्वेश्चन इट हैज बीन told to you to find the maximum possible draft that you can form in a single pass, so understand, so that is going to be is equal to delta h max would be mu square r. Till now, if you have any kind of confusion, you can ask with me. Otherwise, I will go to the next things. Rohit ji, definitely I teach in this same timing. My timing is 10 o'clock. So in this timing only I teach the manufacturing, and on 11 a.m. morning I teach the strength of material in Unacademy app. So till now I have finished the metal cutting, casting and welding, and now I am teaching the forming. So if you have any kind of doubt, then please ask me. Okay, fine. So this is what we have got. Now understand, this is the condition of a single pass. What is the meaning of single pass, double pass? Understand, I am teaching you. See, suppose if you have a roller, and this is a roller arrangement. So this is a billet that you are that billet is entering, workpiece is entering, and this is the reduced diameter that you have got. Fine, this is the reduced diameter that you have got. Now what you are doing, you also want this diameter. See, this is the thickness. Suppose this is the h1, this is the h2. Now you want this h to be more lesser. So how you will do it? You will apply rollers like this. You will give rollers like this. Suppose like this. So the rollers, it will pass will like that, like that. Fine. So again, in the second pass, so this is known as first pass. This is known as first pass. This is known as second pass. This is known as second pass. So this is the condition. This is the condition for a single pass. For a single pass. For a single pass. Fine. Now suppose that there is a rollers like this, and number of rollers like this, right? So now if I would be asking with you, see, if in a question n is the number of pass, if n is the number of pass, that if in a question, if it is given to you that this is h1, this is h2, this is h3, dot 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 dot, everything is given. So if it has been given that suppose h3 minus of h1, suppose h3 minus of h1, this is what, this is the delta h required. This is the delta h required, right? This is what you want to make. Suppose you want to make the h3 from the h1, right? This is what you want to make. So this is the delta h required. Now this delta h can again undergo in different processes, and it can also form like delta h6. So it can also make h6 height, which is what, which is the maximum draft. So there is another which is delta h maximum, and what I can write from here, that if I want to find a number of pass, that is n, that would be given by delta h required by delta h maximum. Right or wrong? So this is the concept of pass. Fine, this is the concept of pass. So I hope you are getting the understanding of each and every formulas, and you have understood these entire concepts very well. Throughout these concepts, if you have faced any kind of problem, you can always ask with me. I would try my level best to explain you which textbook to follow, numericals and concept. Rohit ji, what I can tell to you is that if you are following my lectures, my videos, so you do not have to follow any other textbooks or any other practice materials. You can always go for the practice materials. Definitely practice materials are like, you can always go for the standard things like GATE previous year papers, download it, ESE previous year paper, download it, ISRO previous year paper, download it. So if you are solving these kind of previous year papers and enroll in any of the test series, your preparation would be amazing. Definitely that is going to be amazing. So prepare with these things. These things are for your practice things, and definitely you can watch my lectures. So these things would be self-sufficient. To crack anything. Okay, even if you want, you can always go for the Kalpak Jain book. That is very nice book. Kalpak Jain is very nice book. Okay, so any doubt till now? Okay, so I hope you all understood the concepts, and definitely you have understood everything. So if you have understood these all concepts, so definitely now the time comes to practice the formulas, whatever the formulas that we have seen. Okay, so try to implement these formulas. So before implementing, I would just like to recap those things what I have written here in a just a page, in just a page. Okay, okay. So see here, so I have told you very most important formula, that is tan alpha is equal to mu is equal to root over of delta h by r. Remember this formula, remember this formula. Next formula is what, next formula is what, this is, see here, this is what, this is mu minimum. This was what, this was mu minimum. Fine, this was what, this was mu minimum, right? So let me write it here. This was what, mu minimum, mu minimum. Okay, so this was mu minimum. So this is what we have seen. We have also seen second, that is the length of deformation. So that is BC, and length of deformation is nothing but root over r delta h. Fine. Where what is this delta h? H naught minus of hf. Fine. And this is what, this is the draft, this is the draft, this is the draft. From this only you can find one another formula. From this only you can find one another formula, that is delta h maximum is equal to mu square r. Okay, so maximum possible reduction, that is the maximum draft, that is mu square r. Okay, so now if you could remember these things, definitely you can solve each and every problems. And there is another one formula that I should tell to you, that is contact length. Contact length. What is the contact length? If you have just forgotten, this is the contact length. Suppose this is B, this is the C, so this is the contact length. So see, this is what is what, this is, suppose this is the radius of the roller. Just a minute. Suppose this is the radius of the roller, so this is like this. Fine. So if this is the condition, so this BC is the contact length, this is the R, so this is R, this is alpha, so BC would be R alpha. Fine. So just write it here. Contact length is going to be is equal to R alpha, and the length of deformation is going to be is equal to root over R delta H. Now if you could remember these formula, definitely you can solve each and every problems. Now try to implement these concepts in this formula. Try to solve this question. Try to solve this question and tell me the answer. Now try to solve this question and tell me the answer. Try to solve this question and tell me the answer. Try to solve this question. Say in the single pass rolling operation using 410 mm diameter steel rollers, right? So the steel roller diameter is given, width of 140 mm is there, thickness is 8 mm, undergoes a 10% reduction of thickness, angle of bite, it is being asked. Try to find it. B, C, okay. Ranvin has given answer as 0.062, okay. Hemant has given option B, fine. Okay, what about others? What about others? What about others, my dear friend? See here what is given, 410 mm diameter, right? So what is the diameter? So diameter is given as 410. So diameter is given as 410 mm. A strip of width 140 mm, so width is given, that is B is given, right? So we do not have to do anything with the width, don't get confused. Thickness was 8 mm, so thickness was 8 mm, so earlier thickness was 8 mm. Undergoes a 10% reduction. What is the meaning of 10% reduction? Can you say that? See, 10% reduction, it means that it is going to be, see, delta H. 10% reduction means what? Delta H. Delta H would be 10% of 8 mm. 10% of 8 mm, that is what? 0.8 mm. So this is the reduction that is given, that is the draft that is given, 0.8 mm. So now you have to find the angle of bite. So how you can find the angle of bite? See, this is the 410 mm, right? So this is the 410 mm which is given. So can you write like that? 410 by 2 would be my radius, right? 410 by 2, so that would be 205 mm. You know the radius, you know the delta H. So can you find from this formula tan alpha is equal to root over of delta H by R? Now from here, can you find the angle of bite? Now can you find the angle of bite? Those who have not attempted this question, can you now find the angle of bite using these things? You know the R, you know the delta H. So each and everything is known in this equation. Now can you find the alpha? Can you find the alpha? Okay, so I think that some of you have given the answer and some of you are still struggling to give the answer. No problem. See, I have explained you, this is the radius of the roller, this is the possible draft we have found. Now you have to just put it in this formula. So what you will do it? So tan alpha would be, see, that is root over delta H by R. What is delta H? Is it 0.8 mm? Write it here, 0.8 mm by radius of the roller. What is the radius of the roller? Is it 205? So that would be 205 mm. And from here you will be getting alpha is equal to, so you will be getting alpha is equal to 3.5745. Now see, this is what, this is in degrees, this is in degrees that you are getting. Now always remember that pi radian is 180 degree. So if you want to convert a degree, so 1 degree would be pi by 180 radian. Clear? So if you would multiply these things, then you will be getting the answers. Fine. So if you would change it into the radian, so that would be, alpha would be 3.5745 into pi by 180, and that is going to be give me the 0.0623 radian. Now I hope now you understood this question very much clearly. So that is your option would be option C. So definitely Ranveen has given the very good answer. So Ranveen ji, you have given the correct answers. Okay, so you have understood these questions very much clearly. Now try to solve this question. Try to solve this question and tell me the answer now. Now try to solve this question. Try to solve this question. Thickness of metallic sheet is reduced from initial value 16 mm to final value 10 mm. Right? So there is a roller. There is a roller. So from this roller, you are passing thickness value, and from here it is coming out. So what is this value? What is this value? So this value is what? This value is 16 mm. So H1 is 16 mm. What is this? This is H2 is equal to 10 mm. in one single pass. Now can you understand the meaning of one single pass? Can you understand the meaning of one single pass? See, this is the meaning of single pass and double pass. Clear? This is the meaning. 9.936. Very good, very good, very good. You have given a very correct answer. So this is the H2. 10 mm is this is 16 mm. Fine. So what is the delta H? Delta H would be 16 mm minus 10 mm, that is going to be is equal to 6 mm. So this is the draft that you have found out. 9.82, option D. Very good Ranveen, you have also given the correct answer. So delta H we know. What is the diameter? Diameter of roll is 400 mm. So again, diameter of roll is 400 mm. This is the diameter of roll. So what is the radius of the roll? Is it 200 mm? Is it 200 mm? Now again, you know these things. Again, you know delta H and you know R. Now put these things in the equations. What is the equation? Tan alpha is equal to root over of delta H by R, which is tan alpha would be, again, what is root over delta H? Is it 6 mm? Is it 200 mm? So put it here, 6 mm by 200 mm. This mm will cancelled out, and when you will be finding it, so you will be getting the alpha. Alpha would be just a minute, 6 by 200. So you will be getting alpha as 9.8264. So any doubt? See, in this question, most importantly, the bite angle was asked in degree. So you have given the answer in degrees. Fine. Now in the earlier question, the bite angle of bite was asked in radians. So you have done these kind of conversions, and then you got the answer in radian. So if you have any kind of doubt in these, that what I have, why I have done this, and so if you have any doubt, always and always my suggestion is, my dear friend, study or read the questions very much properly. So if you have done any kind of mistakes in that, definitely do not commit this kind of silly mistakes, because these questions are very much easy, formula based. I have told you this formula, that see here, only these formula will do it. See, there are some more formulas like power, like torque, that I will explain you in the next class, that I will explain you in the subsequent class, step by step. But these formulas are enough to solve almost 90% of the problems, and these is also, so if I would add with those them, add with these things, 100% of the rolling problems will be solved by only 5 to 6 or 7 formulas. That's it. So you just have to understand these things, and understand the applicability of these formulas also. Try to find the answer. Try to find the answer of this and tell me the answer. Now try to find the answer and tell me the answer. Try to solve this question. A strip with a cross section of 150 mm into 4.5 mm is being rolled with 20% reduction area using 450 mm diameter rolls. Okay, so there is a 450 mm diameter roll is there, and by using this roll, this is the thickness. Fine, it is what, 20% reduced. So angle subtended by deformation zone is being asked. Try to find the answer. Try to find the answer and tell me, try to solve this question. Try to solve this question. 0.06. Okay, very good, very good. CCV, what is the meaning? Very good, Ranveen. Very good. 0.0632. Very good. What about others? What about others? What about others? See, a strip with a cross section 150 mm into 4.5 mm is being rolled with a 20% reduction. So see here, there is a sheet. So sheet is what? Sheet is like this, right? This is the sheet. And these kind of sheets are going in the rollers, right? So the roller is like this. So with this roller rolling process, these are reduced. So this is the width. This is the width which is given as 150 mm, and this is the 4.5 mm. Clear? So we just draw like this, that these two rollers are there, and in these two rollers, this is the width. What is this width? It is 4.5 mm. Clear? It is being rolled out with 20% reduction. So what is the 20% reduction means? What is the 20% reduction means? It simply means that 20% of this will be reduced. 20% of this will be reduced. So this would be, so this is H1, this would be H2. So can I say that H2 will be zero point 0.8 of 4.5, because 20% is getting reduced. So 80% would be there. अगर मैं बोलूं कि 20% 4.5 का 20% रिड्यूस हो चुका है, मतलब 4.5 का 80% पार्ट ही बचेगा ना. So if I would do it, then I would get the H2. Yes or no? Now here the 450 mm diameter is given. So diameter is given. So diameter is given as 450 mm. Now from here you can find the radius. From here you can find the radius. So radius will be what? Radius will be 450 by 2. That is 225 mm. So radius is given, right? Radius is given, and this is the draft. This is the draft which is given. So I can write from here, that these things are known to me. Now you need to find the deformation zone. So what is that? Again, apply the same formula. Tan alpha is equal to root over of delta h by r, where what is these things? Delta h. So earlier was what? It was 4.5, again it was zero point 0.8. So 4.5 minus of zero point 0.8 into 4.5 by 225 mm. Now from here, when you will be calculating it, you will be getting the answer in 0.063 radians. So most important thing is there, that you have to convert degree into radian. Okay, so I hope you are understanding the concepts. Okay, can you find this? Can you find this? Try to solve this question. Try to solve this question. Try to solve this question. In this, contact length has been asked from you. Contact length has been asked from you. Okay, in this, contact length has been asked from you. Try to find this answer. Try to find the answer. .72. Okay, very good, very good. So see, Ranvin, if you are finding the if your answer is 38.72, so definitely the answer which is close in this option is option B. So definitely you can go for the option B. Okay, so there is no need to getting confused. Fine. B. Yes, yes, good. Swapnil 38.72. Very good, Swapnil. Very good, Ranveen. What about others? What about others? Are you not understanding? Is there any problem in understanding? What about the others? What about the others? See, this is very easy problem in a rolling process. In a rolling process, sheet of 25 thickness is rolled to 20 So there is a rolling, there is a roller like this. Add on this roller, we are feeding the H1. So what is this H1? H1 is 25 What is this? This is H2. What is this H2? Is it 20 So what is the delta H? Is it 25 minus 20? So delta H would be 5 What is the diameter of roller? It is 600 So diameter of roller is given as 600 So diameter is given as 600 So definitely you can go for the radius, and that is going to be 300 What is the contact length? So contact length would be, stripped contact length would be like this. This is the stripped contact length, and this is, I have told you how you can find it. Either you can find it by using R alpha, or you can do it like this, root over R delta H. Fine. So suppose that I know delta H, I know R. I will put it in this equation. I will get the answer. So what is it? So L would be R delta H root over. So what is the radius? What is the radius? Is it 300? Delta H is 5 So definitely it is 300 It is 5 And from this you will be getting answer as 38.729 which is option B. So I hope you are understanding these questions. Now tell me the answer. Tell me the answer of this question. Tell me the answer of this question. Maximum possible draft in a cold rolling of sheet increases with, what is the answer? Maximum possible draft, what is the answer? Can you tell me? A. Ranveen is telling our option A. Very good. What about others? What about others? See, if you are committing any mistakes, that's not a problem, but at least tell me the answer, because that's how, if you are committing any kind of mistakes, so that mistakes will be nullified here itself, because eventually I'm going to explain the questions. So if you're committing any mistakes, you would be understanding where exactly you are committing the mistakes, what exactly is the area that you should work on, and definitely you will be benefited. So do not hesitate to commit if you are doing any mistakes. That's not a problem, that's completely okay. Okay, so Coolbrat has given option A. Very good. Balram Gupta has given increase in roll velocity. Okay, very good, very good. What about others? Okay, now try to understand. Try to understand this question. I have told you the formula. What is the formula? Where is that? Here is this formula. Here is a devil. What is written? Delta H max is equal to mu square R. Delta H max is equal to mu square R. What is delta max? Delta H max? What is this? Is it maximum possible draft? Now this maximum possible draft is depending upon which? Mu square and r. Fine. So let me write it here. That maximum possible draft delta H max is equal to mu square r. So from this equations, what I can understand that sheets, so maximum possible draft has to increase, so it has to increase. So see here, my delta H max will increase only in condition when mu would be increasing or radius would be increasing, right or wrong? Now from here, understand, increase in coefficient of friction. Yes, if I would be increasing the coefficient of friction, so delta H max would be increasing. So definitely this is the correct answer. So since this is a multiple choice question, you can always go for it. That's not a problem. But let's analyze other options also. Decrease in coefficient of friction. No, if coefficient of friction would decrease, so delta H max would decrease. Okay, so this is not an option. Decrease in roll radius. See, if you are decreasing the roll radius like this, see, if you are decreasing the roll radius, so definitely this is also decreasing. This is also not a correct idea. Now increase in a roll velocity, my dear friend, it is only depending upon these parameters, right? So this is also not an option. So option A is going to be your correct choice. Correct choice. Fine. So now I hope you understood this question also. Now try to tell me this question. Tell me the answer of this question. Again, tell me the answer of this question. In a rolling process, maximum possible draft is defined as the difference between initial and the final thickness of a metal sheet, mainly depends on which pair of the following parameters. Again, same question, same type of question is being asked, but it is reframed in a different way. क्वेश्चन देने के तरीके में थोड़ी चेंजेस है, बट कॉन्सेप्ट वही है. कॉन्सेप्ट वही है. टेल मी द आंसर. Concept is same, but question reframing of the question is little bit different. Very good, Coolbrat and Ranwin. Very good, very good. You all are giving the correct answers. See, in a rolling process, maximum possible draft. So again, yes, the same question, same questions. Yes, kind of MSQ question. Yes, definitely. See, definitely. That's why I am teaching you these things. Concept is very much important. So those who are teaching with me, those who are studying with me, definitely keep this thing in your mind. Always and always work on your concept. If your concept is clear, then only you can go for the MSQ type of questions, multiple select questions, then only you can attempt it. Otherwise, no, there is no chance, है ना? So definitely work on your concepts. So what is the maximum possible draft? You know that maximum possible draft is nothing but mu square r. So what is the options? Roll diameter. Yes, it is depending on the roll diameter, right? What is it? Is it depending on coefficient of friction of roll and work? Yes, it is depending on R and T. So definitely option would be B. Clear? Okay. Now see this question also. Now see this question. This is the question that was asked in GATE 2018. GATE 2018. Very good, Balram. Very good. Hemant, I think you have committed the mistakes. Now I think you can relate where exactly you have committed the mistakes. Hope you understood this question. Now try to tell me the answer. GATE 2018 problem. So can you understand? Tell me the answer. Same question is there. Maximum possible draft in rolling, which is the difference between initial and the of the sheet, depends upon what? So you know that maximum possible draft depends upon mu square and r. Fine, mu square and r. So rolling force, no. Roll radius, yes. Roll width, no. No. So option B would be there. So understand this. My motto is what? My motto is to give you the concept. See here. If you would look it very closely, see, same concept in GATE 2011. But again, same concept has been asked in GATE 2018, GATE 2014. But क्वेश्चन देने के तरीके में चेंज हो गया. What is the change? Change is questions has been reframed in a different way. In a different way. Fine. Concept is same. But concept is same. Again, in GATE 2018, same concept. Concept is same. But what is the difference? Again, reframing of the questions, options. See the options choice. Options choice has been different. Option choice. These things are different. Clear? Now see also the option choice, strength of the work material, like strain. These options are new. So understand the philosophy of GATE, what they are doing it. See, concept is limited with you. You do not have so much humongous amount of endless concept. No, limited concept is there. So questions would be asked from these type of concepts only. So where they are doing the variations, they are doing the variations in this way. They're reframing the question a different way. They're giving the options different. So different options are given. So always and always try to focus on your concepts, and your answers would be definitely every time that was going to be correct. Now try to solve this question and tell me the answer. Tell me the answer. Try to solve this question and tell me the answer. One 1.92. Very good, very good, very good. What about others? What about others? What about others? Do you have any difficulty to understand this question? Same type of question is there. See here, 300 thick slab is being cold rolled using a roll of 600 diameter. Fine. So if the coefficient of friction is given as mu, so mu is given, radius is given. So what is the radius? So see here, diameter is given as 600 So what would be radius? Radius would be 300 Very good, Balram. Very good. Very good, Balram. So radius is given as 300 Now what is the coefficient of friction? That is 0.08. Now you need to find the maximum possible reduction. That is the delta H, right? So you can always go for it. Now can you find it? Now can you find it? Delta H, mu square R, mu square R. What is the mu? What is the mu? So see here, you know the mu, that is 0.08 whole square. R is given as 300 So from this, when you will be calculating it, you will be getting the answers. Okay, so that is delta H max would be 1.92. Clear? Ranveen, see, currently Rajender sir is teaching the industrial. Currently Rajender sir is teaching the industrial, and I am teaching the manufacturing as well as strength of material. So you can follow me in these two subjects. So after the completion, definitely I can go for the different subjects, but as of now Rajender sir is teaching the industrial, so you can always go and watch his lectures also. Okay. Okay, Ranveen. See, Rajender sir is teaching in YouTube. Fine. And see here, I am teaching manufacturing in YouTube and strength of material in app. And that is free. That is free classes I am giving. Okay, that is special classes. Yes. Gorvinder sir is teaching the industrial. Thank you. Rajender sir is teaching the theory of machine. Gorvinder sir is teaching the industrial, and Rajender sir is teaching the theory of machine. Thank you so much, cool bread. Thank you so much. Okay, so actually, each and every faculty is teaching different subjects, so you can follow them at a time so that your preparation gets in a very limited time. Your preparation would be there, and definitely you can follow me here also if you want. Okay. So any doubt in today's session, my dear friend? Any kind of doubts in today's session? Any kind of doubts in today's session? Any kind of doubt in today's session? And if you have enjoyed this session, my dear friend, definitely like this video and share this in your friend circle. And if you're planning for a plus subscription, use my code SIRVK, SIRVK, to get a 10% off, as well as I will provide a personal mentorship to you also. So definitely you can use my code SIRVK. If you have any kind of doubt, you can always ask with me. I'm waiting for your doubts reply. If you do not have any doubt, then also tell me so that I would be ending the session as soon as possible. Sir, one more questions. Okay, you want to do one more questions? Okay, do it. Do it. No problem. I have one questions. Do it this question. Do this question. Do this question. GATE 2006 problem is there. Do this question. Try to solve this question. Okay, so on a special request of Ranveen, I am giving you the one question. Try to solve it and tell me the answer. 2.5 mm. Very good, very good, very good, very good. Ranveen has also given the answer 2.5 mm. Very good. See, in this question, nothing is there. See, that's the beauty. You rolling problems are very easy. Very easy problems are always asked. But see, कितना कुछ लिख दिया, अरे बाप रे बाप, इतना कुछ देख करके ही तो हम डर जाते हैं, है ना? इतना कुछ देख के ही तो हम डर जाते हैं, है ना? इतना कभी भी डरना नहीं है सर. इफ यू हैव अ फियर, डोंट वरी. रोलिंग प्रॉब्लम्स आर वेरी इजी. जस्ट रीड ना, जस्ट रीड. व्हाट इज इट? 4 mm थिक शीट इज रोल्ड विद 3 mm डायमीटर ऑफ रोल. चलिए एक बार ध्यान से लिख लेते हैं. डायमीटर क्या है सर? 300 mm. फाइन. rolled with a 3 mm diameter rolls to reduce thickness without any change in the weights. So definitely I want to reduce the thickness. The friction coefficient at the work roll interface is 0.1. What is the friction? So that is 0.1. Fine, that is 0.1. Now understand, this is given as 0.1. The minimum possible thickness of the sheet that can be produced in a single pass. So what is the minimum possible thickness that you can produce? What is the minimum possible thickness? See here, understand from here. Understand from here. Delta H max, maximum possible reduction is what? Is it H1? Is it H1 minus of H2? Is it H1 minus of H2? Right or wrong? So see here, from this, what you can find, this is H1 minus of H2. So first of all, try to find the delta H max. Try to find delta H max. That is, delta H max would be mu square R. Mu square R. You know the mu. You know the R. What is the R? Is it 150? Is it 150 mm? Try to substitute it here. Delta H max would be mu would be 0.1 whole square. Radius is 150 mm. So definitely that would be going to give me delta H max would be 1.5 mm. So maximum possible draft you got as 1.5 mm. Maximum possible draft you got as 1.5 mm. Now understand. Now understand. Now understand in this way. So there is a roller. These two rollers are there. Now from here you are giving the H1 amount of, this is the H1 thickness. Fine, this is the H1 thickness, and from here you are getting the H2. You are getting the H2. So this is what this is. This whole thing is delta. This is what this is, delta H by 2. This is delta H by 2. Now understand, if I am getting a maximum this, if this is maximum, understand once again, if this is delta H, draft would be maximum. If draft would be maximum, so H2 will be what? H2 will be minimum. Yes or no? H2 will be minimum. Yes or no? Now see, in this question, 4 mm thick sheet is given. So what is this? Is this H1 4 mm given? Now you need to find this maximum. So definitely H2 will be minimum. So how you can find it? So this H2 will be actually minimum. This H2 will be actually minimum. Now from here you just substituted. What is delta H max? Is it 1.5 mm? What is H1? H1 was 4 mm. So that is 4 minus of H2, which is what? Minimum. Which is what? Minimum. And from here you can find H2 minimum would be what? Would be 1.5, 4 minus of 1.5, that would be 2.5. Clear? So you will be getting the answer. H2 is 2.5 mm. Any doubt? See, understanding is, समझना बहुत जरूरी है sir. See why I have explained it. If you could read it, the minimum possible thickness of the sheet that can be produced. So if draft would be maximum, definitely this is going to be minimum. This is the concept. This is the concept. Fine. Non-tech के लिए what I would say you that कुलदीप सर हैं, वो लोग तो एप्टीट्यूड ले ही रहे हैं. So definitely you can go for those things, है ना. एप्टीट्यूड वो सब काफ़ी ज़्यादा इम्पोर्टेंट रखता है ना. मैथमेटिक्स पार्ट, कॉन्सेप्ट्स बहुत इंपॉर्टेंट है, क्योंकि टेक्निकल तो आप कर ही लीजिएगा. डेफिनेटली यू ऑल आर गुड इन टेक्निकल, एंड टेक्निकल नीड्स सम प्रैक्टिस ऑल्सो, बट प्रैक्टिस थोड़ी सी प्रैक्टिस होगी तो कर लीजिएगा. बट डेफिनेटली फॉर नॉन टैक यू नीड ए लॉट्स एंड लॉट्स ऑफ प्रैक्टिस. बहुत ज़्यादा प्रैक्टिस की ज़रूरत होती है, बिकॉज वी इंजीनियर्स लैक इन दीज थिंग्स, है ना. हम टेक्निकल तो बहुत अच्छे से कर लेते हैं, लेकिन नॉन टेक नहीं कर पाते हैं, और डेफिनेटली आपको प्रैक्टिस मांगता है डेफिनेटली. सो फॉर दैट आई वुड एडवाइज यू टू practice what I can say as of now. Okay, so I hope your preparations are very good, my dear friends. Each and every one you are preparing for in a very good way, and definitely if you have loved my sessions, if you have liked my session, definitely like this session, definitely like this session, share with this your friend circle, share in your friend circle, so that you are getting benefited, they are getting benefited, so it's a win-win situations, right? So thank you so much for being so much actively listening my lectures, understanding the concept, because eventually you are making this lecture to be very beautiful. And again, if you are if you want to purchase the plus subscription, so use my code SIRVK, or anyone in your friend circle is going for a plus subscription, refer my code SIRVK. So thank you so much for your active participation. I'm ending this session. I assume that you don't have any kind of doubt, or if you have any doubt, send me the message and I would try to resolve it. So I would be live for like a minute, and then I will be ending the session. Okay, then I would be ending the session. Okay, so good night, thank you so much. Thank you. I'm ending this session.